This evening I want to talk about my experience in how reviews and inspections could be used in different ways than normal. Normal reviews are usually done to find problems in documents, in code, in designs, in requirements. But I found interesting ways how it can cause other interesting things. So, for those who don't know me, I'm Niels Malotto. I coach projects, organizations, people to deliver better results in less time. Right result at the right time, I call that quality on time. By birth, I'm an electronic engineer, and I've designed many electronic products, but I do also the coaching to teach other people how to deliver quality. So, about quality on time, Capers-Jones is a guy who measured a lot of stuff in software projects. And he used a lot of material from IBM. On the bottom of the slides, you can see a link to a book I found at Google from Capers. And one of the things you can find there, the most effective way of improving software productivity and shortening projects schedules is to reduce defect levels. And another text I found there, formal inspections are used to prevent defects from occurring and remove defects that did occur. And that's not just hope or so. No, it was measured because IBM measured everything. And it took years before they actually believed their numbers. But they found these as conclusions. And, well, if you prevent defects and you remove the defects that did occur as quickly as possible, you get faster the right stuff. So, last week I was at a testing conference, and it's interesting to see testers are so obsessed with finding bugs, where actually I think we don't want to find bugs, do we? I mean, they shouldn't be there. Anyway, so just some modeling. Of course, some people have seen this. Don't run away if you're agile, because this is what some people call the waterfall picture, figure 2 from Winston Royce. And I just want to show something. I know all models are wrong and some are useful, because even in Scrum, every sprint should do this, I think. This is figure 3 in Royce's paper, and this is figure 10. Now you can imagine if any agilist had read this paper, they ran away and they think, let's focus on coding, testing, and operations. So let's have a look what more we can do to get quality faster. The V model is the folded waterfall, where they want to show that based on the requirements, you can make the test for the end. Based on the design, you can make test cases for the design, etc. Now, the problem is that the most expensive errors in any design are in the requirements. And you find them at the end, so that's not a good idea. That's why some people created the W model, which shows that you can write requirements, you can test the requirements, you can specify, you can test the specification, you can design, test the design. And here we have the implementation. At this moment, you can test in software code running, but actually all these are the same product, only in a different form. And how can we test these forms of the product? Well, by modeling, by scenarios, by reviews, inspections. And that's what I want to talk about today. Now, we are people, aren't we? People make mistakes. We are people, so if we have produced something, there are problems, right? Let's be realistic. Now, the longer the problems stay in our product, the more it costs to find and fix them, if we find them and if we can fix them. So, when do we solve the problems we just introduced? Immediately after making the mistake, instead of waiting later. Preferably by preventing, of course. Prevention costs much less than inject first. Put the error there, put the defect there, then you have to find it. You can hope you can find it. You hope you repair it. You see, that's 3 times as expensive as just doing it right the first time. So there's a huge budget to feed prevention. Now, Dijkstra, the first programmer of the Netherlands, he called himself, he said, it's a usual technique to make a program and then to test it. But program testing can be very effective to show the presence of defects. But it's hugely inadequate for showing their absence. So, conventional testing using that very effective way, because the tester thought, well, if it's so easy to find defects, let's find them. And let's not think about that second sentence. It's hopelessly inadequate to show the absence. Because in my zero defects talk, I talk about testers, what do you do if there are no defects? How can you prove there are no defects if there are none? So the challenge is making sure that there are no defects. That's the task of development. And how to show their absence if they're not there, where testing probably is not the right approach. So, now, in all these testing conferences, where I seem to end up at many testing conferences, and I try to teach these testers something, and they think they are QA engineers. Last week, I did a workshop at the conference for testers, and I asked, what is your job? I'm a QA engineer. What are you doing? I'm testing. Okay. So what we normally see is develop, test, and if we find an issue, we repair. And then we go on with the work. But what we should do is we develop, we check that it is okay. If it is not yet, we do something about it, and that is twofold. How can we prevent this ever happening again? That means we are feeding the prevention process. And until the developers have learned to prevent making this error again, we have to improve the sieve that they didn't catch it immediately after injection. And of course, that's the plan to check act, the Deming cycle, or some call it, Deming called the plan to study act. I know, Tom. And of course, you can see a little bit more explanation at the TestCon 2018 video you can find on my conferences pages. Beginning of the year, I did the same talk for BCS, but I think the video from TestCon is more lively because it was not a webinar, because it was on stage. So the idea is no proliferation of pollution. Make sure that what we have to achieve, we call that a requirement. If we review that and get rid of the pollution of that, we can have a good design. If we don't get the pollution out of the requirements, the design will be polluted, the code will be polluted, and the result won't work. So that's the process. And then the idea is at the integration test, I use that with teams, no questions, no issues. If we deliver something to stakeholders to see what happens, we give it to them. And the moment they have one question, one issue, we say, we failed. And actually, that's the approach of the clean room software development approach, which is from the 70s, where they said, if in the final test we find an issue, you don't clean your code, you go back to your design. Now, the problem is usually there is no design because there's only code, right? Be honest. I was a few years ago at the test conference in Hungary, in Budapest, and there was a nice old man. He said, I was the first tester of Hungary. He made a test company, and his first client was Siemens. And they sent him a module for a nuclear reactor software. Can you imagine? That's useful to get rid of any errors in that software. So he said, we tested the module and we found about 300 defects. And then, because there was, of course, no design, we only got the code. He said, then we reconstructed the design from the code, and we found 3,000 potential issues. The thing is, the things you find in the review, often you don't even find with testing. So, if you ever test your own code, or have others test your code, or if you are testing code of others, yeah, ask for what I call the design log. This is what I call the design log. That's my concept of how to put it in a design text. And in the next slide, I'll show some details of that. So the concept of the design log, we put it in a computer, not lose notes, not, well, of course, in the whiteboard, but if it's on the whiteboard for the discussion, that works very well. Take a picture or take the essence into your document, text, drawings, chapter per subject, yeah, to find. And we have reasoning, assumptions, questions and answer, calculations, pictures, possible solutions, selecting criteria for the possible solutions, a decision, how to achieve what we have to achieve. And then, of course, we do something and we find it was a nice idea, but it doesn't really work like that. So in a new date, we say change our idea and we repeat some of this piece, which means at the top of every chapter, we have what we have to achieve. And at the bottom of every chapter, we have the decision how we think we're going to achieve it. That's my concept of design log. And actually, you can ask, nice story, but do you do that yourself? Do you eat your own dog food? Well, I eat my own dog food. This is a list of 20 files I produced in a product I designed a few years ago for some client. Yeah, where I really put the file names already on the subject. So if they want to find some why I designed something in a certain way, then they quickly can see on the text of the file already where to look at. So this was after cleaning up. Of course, during the design, I fill my design log, logging my way of thinking. And at the end, and fortunately, the customer was clever enough to let me spend some time on cleaning up all these files and give it to them. So, just to give some cases using this technique. I was asked by a guy, James, who invited me at another company earlier, but now he was at a new company and he said, Niels, I have here a team, and I asked what's the goal of what we want to achieve, and they didn't have a good answer. So can you come with some requirements workshop? I said, okay. So I went there, and well, at the end of the day, we had some idea what their project was about. Then he said, well, it's Thursday, and once Thursday every month we go to the pub. It's our pub day. So come with us and have some wine and some bites. We went to the pub. So in the pub, James came to me and he said, Niels, this is Louise. Louise, this is Niels. He taught me about design logging. Tell what happened. And he left. So Louise started explaining, we had only 7 days to finish some software. Only 7 days. We were working hard, coding, testing. And have you seen that picture? I found it on the internet somewhere. Somebody proudly showing how they worked. Well, James knew better. He said, stop coding and go back to your design. Yeah, but you have only 7 days. Go back to your design. Apparently, James came in this company at a level where he could say, stop coding, go to your design. So Louise said, I went to my design, found the problem, corrected it, cleaned up the mess. That's also important because in all this coding testing, usually you create a lot of junk. So we cleaned up the mess and it was done in less than 7 days. Thank you, she said. So I made a web page. You can find the story at Design Log Case P here at this link. I made the web page and I sent the link to James and I said, James, can you talk with Louise and ask whether I understood her story well? So James came back to me and he said, Niels, it was even much more interesting. I gave the design to 2 colleagues to review. Yeah, I sent an email with her document and said, can you review this? And of course, a copy to Louise. And then Louise said, if they're going to review, I have to do it much better. James said, you've done your best. Let's see what happens. And based on the review, you can make it even better, if necessary. So, some minor errors, some typos were found, because the problem is people without education, how to review, how to inspect, usually find hardly anything. With education, suddenly they find a lot. So then James said, okay, now let's go to a final review. And there came in another guy who wasn't in the first review. And this guy said, Louise, if we do it in this way, we get deeper and deeper into the mud. We have to do it completely differently. So the solution together, they completely reworked the solution. And then James said, actually, her team had 2 features to deliver. Actually, the one they reviewed this way was crucial for the success of the delivery. He said the other one they did in the old way without all this review stuff. And it was a source of quite some defects, he said. Can you imagine? So James said, from now on, we use design logs to be reviewed before coding. So the title is Using Reviews and Inspection in Various Ways. The review caused them not to implement a bad solution. Isn't that great? Problems of the original solution would not have been found out until much later, was their verdict. And the whole process allowed them to deliver well before the deadline rather than after. Isn't that an interesting result of this? So, well, I've done a lot with James. This was in the first company where he invited me. And I had been working with him and with his teams already for planning and so, but then he said, okay, now we are ready. Can you teach us inspections? And inspection is just a special case of review, a formal way of doing reviews. So I said, well, knowing these people, we shouldn't dig too deep in this inspection stuff. So I gave them a short introduction and then I asked them, guys, do you review? And they said, yeah, we are reviewing, like most people do. So I said, okay, if you do that, let's take a baseline from how you currently review. So take some document, take 1 page out of it, just randomly take a page and multiply it by 20 and give everybody this page. And then when everybody had the page, I said, now you review. And I waited, and after 5 minutes, people started already looking at the ceiling. And I said, are you done? Yes, we are done. Did you find anything? Oh, not really. Okay, now, in inspections, we have rules, and rules are the law of the document. Yeah. So an issue there by definition is a violation of the rule. And I said, let's introduce one rule. This is a design document. And if you don't know what design is supposed to accomplish, how can you know that what's written on this page is correct? I said, now review again. And before long, we saw a lot of yellow lines in all this text. This I can't judge. This I don't know whether it's the right thing. This, etc. Interesting. So actually, the problem was an improvement of a data log function in these devices that were used for building automation, air conditioning, and lighting, and so on. And the story was there were some glitches when the head office or local PCs wanted to collect the data log data. So something had to be repaired or improved, and that was the description in this document. What was the result of it? James said, okay, from now on, it's not allowed to code until the design log is reviewed. So we found that the document that was there didn't show why we wanted to do something and whether what we wanted to do was correct to solve that. So he said, first, you make a design log, then we review, and if we're happy, then you can code. It took a few weeks. I went back home, and every week I sent him an email. How's it going? He said, Niels, you're delaying my project. The only thing he did was change the file name into design log. At least some acceptance there. But for the rest, apparently he had no clue what I actually meant. So one weekend, I took some time to write down a few pages, knowing the background of his project, to show what I thought could be in these in such a document. And then it was quiet for a week, and then suddenly he came with the result. I gave an example, and he came with a solution. He said, Niels, you know the solution? I'm not going to implement it in these devices. I talked with the software guy with the PC software, and we decided to do it in the PC instead of in the documents, because otherwise in these devices, we would get into trouble. So at least he was honest enough to say, Niels, thank you, you saved my project by insisting in thinking about this and deciding not to do it in this device. Well, did I do the same? Well, I already showed you the long list of files I delivered with another project. So I did the same. And when I came home from this meeting, I went to my loft and checked all the papers lying there. Did I really do the design logging myself? Yes, I did. So if you tell people to change, you get resistance. Yeah. If people tell themselves they should change, there is a chance. Yeah. So how to do that? Well, first let's have a look. I found the actual file that he sent to me. For this presentation, I checked that file, and I found this interesting, nicely crafted text. A number of firmware-based methods of removing the glitches from the data log reading process have been investigated. But it has been decided to go with a mechanism implemented in the external system, reading the data log to remove the glitches. External system is the PC. So moving the problem from here to there. Isn't that an interesting description of his design log text? So in this case, using inspection in various ways, what if I would have suggested that the document wasn't right? Resistance. They showed themselves that it wasn't right. But instead of proceeding further with inspections, I thought, let's focus first on thinking what design is about, because a lot of developers have to learn what actually design is about. The third case, City of Amsterdam. A friend of mine said, Niels, we have a project and we have a request for a proposal for software companies to develop some software for us. And can you teach us inspections? And we want to use this document for the exercise. I suppose he already sensed some trouble with the document. So I went there, but before going there, I said, careful, careful. Normally, every time I do this, people ditch the document after the course because it's so bad. You can imagine the reaction at that moment. And you also can imagine what happened after the course. They ditched it. Even more interesting, they redefined the whole product, because having very carefully looked at the text of the document, the way we teach that, and I see Tom Gilp listening in, and he taught me these things. So by really understanding their own text and what it should be, they said, well, this is a dangerous document. We have to redefine the whole project, because, you know, suppliers, they love unclear documents. They love it because they can sell many more hours, first doing it according to the document and then finding out it's not right and then having some iterations and things like that. So they love that. And the city would have gotten a great solution for the wrong problem. So, interesting result of this inspection course, I think. Okay, another thing I always like to say in this respect is early inspection. And you see here the initials of Eric Simmons, who gave me these slides years ago, and he said, Niels, you're the first person outside of Intel who sees these slides. So I think Eric also said, actually, he got us from Tom's book. Yeah, and Tom called it agile inspection, just for the hype word. But I like to call it early inspections, because the idea is, if we know we are people make mistakes. So if we are making some document, being it requirements, being a design, being code, we're in the process of injecting defects, right? We are not perfect, but the customer shouldn't find out. What are we going to do about that? So instead of waiting until all the defects have been created in the document, let's have the person produce some piece of the document, and then we say, can you give it to us? Can we have a look? And then within an hour, we plow back what we found, and then the person can repair what we found in the first piece and prevent in the remainder. How about that? Not waiting until all the defects have been injected. So we do an initial review. Two examples from Eric. One, a large e-business application with 8 requirements authors. Whether that is appropriate is another story. Let's not go into that for the moment. Yeah, because we're talking now about the process of how inspection can help us. So each of these 8 authors sent the first 8 to 10 requirements. So in total, about 100 requirements per author. Sorry. So there were about 100 requirements per author, and they sent the first 10%. Yeah. So within a few hours of submission, we gave back the review result if you wait a few days, they continue working, so it doesn't work. So you have to immediately throw back what you find within 1 or 2 hours. So the authors integrated suggestions and corrections, then continued to work. Some authors chose additional reviews in the meantime. And at the end of the total document, they had the formal inspection for the whole document. What was the result? At the first sample, they found on average 8 major defects per requirement. 8 people, 8 to 10 requirements in review, so about 80 requirements, on average 8 major defects per requirement in the initial review. After that, in the final document, they found 3 major defects. So now we can calculate, and Tom also taught me how to calculate the benefit, because you have to explain your manager that you're spending this time on all this reviewing where the managers think, didn't they do a good job in the first place? Well, they did, but they're people. People make mistakes, just like you and me. So this is what we have to do. But if we calculate the financial benefit, maybe your manager understands better. So Eric showed me his calculation here. The time investment of the whole process, 26 hours. 12 hours initial review, that is 1.5 per author, 8 authors, 12 hours. About 8 hours additional reviews. And then final inspection, 2 hours, 2 checkers, plus preparation and debrief, 6 hours. Major defects prevented from 8 to 3, so 5 prevented in the whole process, which means about 750 requirements and 5 major defects prevented per requirement. If you are not educated in inspections, you don't believe what we are saying here. Every requirement can have 8 major defects. How is that possible? Well, once you get and that's why the education in inspections is so important. Once you have that education, you know this happens. But let's not go into that for the moment. So, major defects prevented 5 per requirement in 750. We saved 5 times 750 requirements. Let's say 10 hours to find and fix later. And now 10 hours more if we find and fix it later. That is so many hours saved. But then we say not every error, because developers are not stupid, not every potential error in a requirement actually ends up as an error in the product. So we say divide by 3. So 12,500 times $50, $500,000. With that number. And what was the investment? What was the investment? 26 hours times, maybe a little bit more expensive people, $2,000. So he also has an interesting example where it's not just used for developers, but also for test cases. Yeah. Testers usually think that developers are a little bit stupid and testers know what to do, right? Well, I think testers are also people, and people make mistakes, so they also make mistakes. So let's see how the making of test cases. Somebody was writing test plans. Again, whether that's a good idea, that's another story, but he was writing test plans. Early inspection used on an existing project. So the test plan was already there. So to simulate the result of early inspection process, they said, let's first take a sample. Yeah, we simulated early inspection by taking a sample of 6 randomly selected test cases out of his document. We brought back the results. The author notes the systematic defects in the results, so reworks the whole document accordingly. So we find not every issue, but issues often are caused by tendencies of people injecting defects. So if you find certain defects, they may be similar in the rest of the document. So he reworks the whole document with the list of issues found. Second round, we took another sample of 6 more test cases, and the quality was much improved. And then the test plan exits, the process goes into production, and the author goes to the next test plan. What was the result of this exercise? First round, 6 major defects per test case. After throwing back our review results to this person, he reworked the whole stuff, and in the second round of inspection, we found 0.5 major defects per test case. Okay. Time investment, 2 hours initial review, 36 hours total in final formal inspection, including rework, blah, blah, excluding rework, and then etc. And then Erik said, historically, about 25% of all defects found by testing were closed as functions as designed. That means the tester thinks it's wrong, but with more investigation, it means that the tester didn't understand it well, and the result was actually right. But still, it took 2 to 4 hours for each of these to find out whether it was a negative or a positive result. This test plan had found about 1,100 software defects, with only 1 defect closed as functions designed. Instead of 25%, only 0.1% was wrong in the test plan. Time saved, 500 to 1,000 hours, 25% of 1,100 defects times 2 to 4 hours. Well, how much is that? About $50,000. So, and then interestingly, Erik added defect prevention in action. The first inspection of the next test plan of this person, 0.2. So apparently after this exercise, he had been thinking more, and when he wrote his new test plan, he worked on prevention. Prevention is so much cheaper than first injecting the defect, trying to find it and trying to repair it. Just a few words at the end. This is a little bit old book. It's called Software Inspection. Actually, it should be called Document Inspection, but then nobody buys it. By Tom Gilb and Dorothy Graham. And we know the process described here is very heavy. But when I started experimenting with inspections, I just used this recipe as a recipe to do it. And once I had done it, I say, now can I tailor down? Like Eric Simmons always says, don't tailor away, tailor down. But in order to be able to make your process simpler, you have to understand the meaning of the process, what you can tailor down and what you cannot. An important element of this is the optimum checking rate. And I want to finish here with an interesting observation I had. First, define what is the optimum checking rate. The most effective individual speed for checking a document against all related documents. Because if you check a document, like the example where they reviewed the design document, where I said, where's the source? Don't you need a requirements document to know what this design should do and what it shouldn't do? So it's not just reading code or reading text in a document, it is checking with any other stuff to see whether it's consistent. So it's not the reading speed, but the correlation speed. And if you don't use this, you get a bad estimate for the remaining defects, as we call it. The optimum checking rate mentioned in the book is 100 to 250 source lines of code per hour, or 1 page of 300 words per hour. We call that a logical page. That's why you cannot inspect a whole document of 100 pages, because you don't have the time for that. And that's why we sample to measure the quality of the document. Now, why do I tell this all? I had been in an inspection course by Tom Gilt. But then I was in Portland, Oregon, and there was Dorothy Graham giving actually the same tutorial about document inspections. So I thought, will Dorothy say the same story or maybe a different story? So I listened in and I got a very aha moment here. She showed me this picture. If what people normally do in their reviews, I've seen so many people doing reviews without education how to do that. And they go through all the pages, because the author, I had authors always saying, I want them to check my whole document. I want them to find all the things I made wrong. Yeah. So if you do that without the optimum checking rate, Dorothy said, well, you may find a minor issue, a major issue, a minor issue. It is fixed, and then people think now the document is okay. But, she said, if we do the not quickly through all the pages, but if we deeply study just a sample of one or a few pages, we can, as she calls it, find the deep-seated defects. If we take this sample, we can find the deep-seated defects. And then, because people have a tendency of injecting similar types of defects, once we have these found, people can find similar ones in their own document because they know their document very well. So this needs the optimum checking rate to get to the depth to find these issues. So my aha was when she told me that. In the first case, we take a sample, a horizontal sample. In this case, we take a vertical sample. And you can imagine the difference, but we didn't feel the difference until this explanation. Yeah? Having a horizontal sample, you find only the obvious issues. And going in a vertical sample, you find the less obvious things that could be even more devastating. So, reviews and inspection used in various ways. I showed you the design log concept, the case in the pub, where the reviewing caused a design change, the case in the data log problem, reviewing caused a concept change, reviewing from the city of Amsterdam caused ditching the document and redefining the project completely. And early inspection, we saw how we can prevent the requirements defects to save a lot of money, and test case review, how the test case writer learned very quickly to make proper test cases that didn't give false positives. And we showed the optimum checking rates to find deep-seated defects. I could have made it a little bit longer, but I think this is a heavy enough shower over all of you to contemplate.